All right. I want to introduce our next speaker. Okay. Let's see here. Yes. Our next speaker is Dennis Beatty. Dennis Beatty is the CEO of Surge, which is the easiest SMS API for developers. As a CEO of an early-stage startup, he doesn't spend much time doing anything outside of work, except for hanging out with his wife and daughter, and cooking. There's always time for cooking. Dennis's talk is titled AI Agents Exposed, TypeScript's Hidden Powers Revealed. Please welcome Dennis Beatty.
So I had the goal of creating the most clickbaity title that I could, and I think that I got the most clickbaity title in the conference, so I'm very proud about that. But I want to start with a story, and this story is very obviously fantasy. This would never actually happen. But this story is about a group of engineers working at a company, and the CEO has just learned about this new technology called AI, and decides, oh, let's have a hackathon. Let's find all the places where we can put AI into our product, and let's add AI to our product everywhere that we can. Now, obviously, that would never actually happen, right? The CEO is never going to force you to add AI to a product when customers don't actually need that. I can make fun of CEOs because, like he mentioned, I am one. A year ago, I started a company called Surge, and prior to starting Surge, I was very skeptical about AI. I had played around with GPT-2, GPT-3, when ChatGPT came out. I thought it was really cool, but I didn't really see a great use case for it other than kind of your typical, like, create a bunch of AI slop for SEO purposes. And so once I created Surge, so I left my job. I'd been working at Entrada, a local tech company. I quit my job. I convinced my brother to quit his job. We started this company, and we got into a program ccalled Y Combinator. And Y Combinator required us to move out to San Francisco for a few months, and we were able to hang out with some really smart people working on some really cool products. And a lot of them were building really cool AI agents. And prior to that, I had worked plenty with LLMs. I had tried out so much, but seeing AI agents in action is what really got me interested in AI. It's what helped me to see the vision for where AI can take us. And so that's kind of what I want to help you all with today, is helping you to kind of see that same vision. AI is not something that we should try to foist into our product and have there just for investors to feel good about continuing to support the company. But AI is a tool that we can have in our tool bag so that when the situation arises, we can build really cool products that solve customer problems. So I need to warn you in advance. I have a 4-year-old at home, and so our sense of humor is a little bit degraded at this point. So as an example of what you can do with AI, if you give it a prompt, it's going to respond with text. Now, the way that that happens is your prompt is converted into what's called tokens. The LLM is going to take those tokens, and it is going to generate the most probable completion for what would come next. It's going to pass your input prompt through a series of layers called transformer layers, and that allows it to simulate understanding so that it can give you the most probable text that comes next. Now, one thing I need to note is that AI, LLMs, are non-deterministic. So you'll notice here, this haiku that was generated, and this is actually a haiku that ChatGPT generated for me, is not a valid haiku. The second line has 8 syllables, and if you've written haikus before, you know that they should be 5-7-5. The LLM is not always going to be right, and it's not going to give us the same output every time. So as you use AI as a tool, that is one of the things that you have to keep in mind. Now, I mentioned that I started this company called Surge. Surge is the easiest SMS API for developers. If you have written an application that uses SMS in the last 5 years, you'll know that the hard part of sending SMS messages is not the actual sending. The hard part now is the registration and compliance. About 5 years ago, the FCC required that all SMS APIs start to require a registration process. Now, Twilio makes it so that that registration takes 2 to 3 weeks. You submit a bunch of forms, and then 2 to 3 weeks later, you find out if you got approved or not. One of Surge's big capabilities is that we can do that in 2 to 3 days. And one of the big differences there is in automation. Now, this page is one of the most important in our registration flow. Twilio doesn't tell you in their registration flow that they're going to be checking your privacy policy. The carriers require that you not share SMS consent with third parties, that you don't allow affiliate marketing for SMS. And so every registration that goes through Twilio, a person manually pulls up your website, finds your privacy policy, looks through that privacy policy, and makes sure that it's not going to allow affiliate marketing. Now, this is something that 5 years ago, when this registration process went into effect, there's no way to automate that. LLMs have made it so that that is completely possible to automate now. So what we can do, and what we do at Surge, is we provide snippets. We provide an example SMS privacy policy that you can add to your site, or we give you snippets that you can add to an existing policy. And then we ask for your privacy policy URL. When you provide that URL for us, we can then go and use Puppeteer to pull down your privacy policy and get the text for it. Then we can pass that through an LLM and tell the LLM, get the portions of the privacy policy that are relevant to sharing data with third parties. Then we can pass that text through a second LLM and say, okay, take this and tell me, does this allow for sharing SMS consent with third parties or not? And based on that, we know if we can reject or approve that campaign. And so by using LLMs as a tool, our application is able to make a determination of whether or not your application should be approved or rejected. We're able to use LLMs as a tool from our application. What gets really interesting is when we switch that around. And instead of our application using the LLM as a tool, we allow the LLM to use our application as a tool. So there's a concept called agency. As humans, we have agency. I can pick up my water bottle. I can set my water bottle down. Just the act of talking, I am changing the pressure in the air to make the sound go toward you. As a human, I have agency. I can exert my influence on the world around me. Now, one way to look at this is the idea of thermostats versus thermometers. A thermometer can measure the temperature, but a thermostat has agency because it can use the tools it has. It can use its connection to an air conditioner or to a furnace to actually change the temperature of the air. It affects change on the world around it. We can give those same tools, we can give muscles to an LLM, allowing it to become an agent. And so the way that we can do that, well, let's start with an example first where we're not giving those tools. So if I ask a human, how's the weather in Salt Lake City? You could, well, you can't in here, but if we were somewhere else, you could look out the window and you could say, oh, it's sunny outside, or oh, it's cold outside. Or you could pick up your phone and you could say, okay, my phone says it's 72 degrees and sunny outside. Now, an LLM only has the data within it that it has been trained with. Its transformer layers were trained on lots of historical data, but they don't know what the weather is going to be on September 12th because they were trained in the past. And so if we want an LLM to be able to tell us what the weather is, we need to give it the ability to find that out. We could give it access to a camera feed so that it could see outside, but even easier would be giving it access to an API that it can call to be able to get the current weather. And so the way that we can do that is by splitting up our prompt. So like I mentioned, when you prompt an LLM, we are giving it a series of text, of tokens, that then it is able to calculate the probable next set of text that would come after that. We can split our prompt into two pieces, a system prompt and a user prompt. The system prompt gives the LLM instructions for how to handle the user prompt, and then the user prompt is the question or the text that was entered by our user. So in this case, we can tell the LLM, if the user asks for the current weather, output a JSON object that represents a call to a tool called getWeather. And that tool is going to need some arguments. It's going to need the location that we want to look up the weather for. Then our user prompt is going to still be that same, how's the weather in Salt Lake City? Now, when we send that to the LLM, it gets combined into a single prompt, into the single input that then the LLM is able to act on. The LLM then is going to be able to follow those instructions, and it's going to output for us that JSON object that we asked for. And you'll notice that it will fill in the arguments so that it'll say, I want to get the weather specifically for Salt Lake City. Now, I should say that JSON isn't a necessary thing here. The important part is that the LLM be able to provide a format that our application is going to be able to process. So our application then is going to listen for this specific JSON, and it's going to then call an API to get the weather for Salt Lake City. We're then going to provide the response back to the LLM, and then the LLM can use that response to return, okay, it's 72 degrees, mostly sunny, light winds, no rain expected. And so by giving the LLM the ability to make that tool call to gather context about the world around it, it's able to provide better functionality than it could if it's only relying on its training data. So let's talk about some LLM capabilities that I think more of us have used. Quick show of hands, how many of you have used a code completion tool like GitHub Copilot? Okay, most of you. Okay, how many of you have used LLMs to chat with, like pasted code into ChatGPT or used, Cursor's Ask mode? Okay, and then how many of you have used a coding agent, like Claude Code or Cursor's Agent mode? Now, Copilot is really interesting because it gives you probable snippets of what come next. When you do code completion, that's what it's doing. It's taking your existing code and giving you a snippet of, this is probably the code that would come next. When you're using ChatGPT or Cursor Ask, it's going to use, Cursor Ask is going to use a tool to get the code, but it's going to just return answers, basically just like the weather application that I was just showing. It will get your code to be able to tell you what you want to know about it. But where it gets really interesting is when you get into Claude Code or Cursor's Agent mode, because then you're not just having the LLM get context on your code. You're giving it tools so that it can actually write code for you. It can actually do the work for you. And that's when you, as a developer, are able to have a multiplicative effect on the way that you work. So with Claude Code, it has several different tools that it can use. When you ask it to do something, it's going to use one tool to grep your code base, to find the relevant files that need to be changed. It's going to use another tool to actually generate diffs, to determine, so the LLM is going to be able to say, okay, this is the change that needs to be made, and then we can use another tool to apply the diff, to change your code file to match what the LLM has said it needs to have. We can use another tool to run your tests, to run your linter, to run prettier. And so it's able to check and make sure that the changes it made are having the effect that's expected. Now, I should say that agents bring other concerns. Everyone's a little bit afraid of giving an AI agent full access to your computer. And I should say that agents do need guardrails. It's really similar to working with a junior engineer. You're not going to give them access to your production database on day one. Or if you do, then you're accepting that risk. It is something to be aware of, but the more autonomy that we can give the agent, the more effective it can be. So I had a lot of fun making this slide. I want to talk a little bit about Python. So one of the things that, one of the myths that I think exists in our industry is that anytime you're doing anything with AI, it needs to be done in Python. Well, you'll notice in this talk, I've mentioned several times that there is a delineation between the application and the LLM. Those are two separate things. If you are a machine learning engineer, if you're a data scientist, Python is the language to be working with. If you're training an LLM, you want to be using Python. But I don't know about any of you, but I am not building an LLM. I'm not training ML models. I am a software engineer working to solve problems, oftentimes with code, and I am working to build applications. And so for what I'm doing, Python is not necessary. The LLMs have already been trained, and I can use TypeScript or whatever language I want to call that LLM. And so I could talk about how TypeScript is the best language for AI agents because of things like its async await patterns, that because you're working with network calls, you're going to be making lots of network calls when you talk to LLMs. And so the async await pattern makes that really nice. I could talk about how type safety makes it so that the code that we generate with LLMs in TypeScript is going to be more likely to be correct. I could talk about how the ecosystem churn in the JavaScript ecosystem has prepared us for the churn that's happening with AI models right now, constantly coming out with new models every week. But the truth is that the reason that TypeScript is the best language for building AI agents is because it's the language that you know. When we're building applications, having a language that we already know is going to allow us to build an application as efficiently as possible. So I could give this exact same talk at a PHP conference, at a Ruby conference, at a Go conference, and the principles would be the same. When you're building an AI agent, you can do that in whatever language you want to use, whatever you know best. So I want to talk now about how to build an AI agent in TypeScript. So I've mentioned that, Surge is the best SMS API for developers. You can install our Node SDK with a simple command. I do need to warn you here, the code is a little bit dense. Don't worry too much if you don't catch everything, because I do have a link to the GitHub repo at the end. So we're going to build a very simple scheduling agent. So that starts with an Express server. So to start out, we're going to need to define our Surge SDK and create our client. And that requires an API key and a webhook signing secret. Now, once we have that in place, we're going to start listening for webhooks. We want to be able to schedule users. In this example, I've created it as I've called it Alpine Pup Parlor in Salt Lake City for dog grooming. And so we're going to help people with dogs schedule an appointment to have their dog groomed. So what we're going to do is we're going to listen to webhooks from Surge. Every time a new text message is received on your Surge phone number, that will hit this webhook endpoint. So first off, we're going to unwrap that webhook that we receive. And so what that means is it's validating the signature to make sure that it came from Surge. And then it's going to create a typed event object. So then we check and make sure that the event is a message received event. And we can filter those in Surge, but we still want to add that check here. Now, once we've received that event, we can pull the first name, last name, and phone number from the Surge contact and use those to find a customer in our database. We can see, does this phone number belong to someone who has interacted with us before, or is this a new customer? And this gets really important with LLMs because we can create much more personalized conversations with someone when we know more about them. In this case, we're only using their first name, last name, and phone number, but you could add information about their dog. You could say what type of dog it is. And the more that you can provide that information, the better the conversation you can have with that person, and the more fun your application can be. So once we've found or created a new customer object, then we're going to call our agent. And so I'm going to come back to this in a minute, but we're going to call our handle incoming message function with the body of the message that was received and the information about that customer. Then we're going to take the response that we receive from the agent, and we're going to use the Surge SDK to send that as a text message back to the customer. And finally, with every webhook, we want to return a 200 OK. So diving into our agent, this is our system prompt. So the prompts I was using in the examples so far have all been really short. When you're building real agents, your prompts tend to get much longer. And don't worry about reading all of this. We're going to look at it more from a high level. So we're going to start off by introducing the role of the agent. We're going to tell the LLM, you are a receptionist for Alpine Pup Parlor, helping people to schedule appointments. Then we want to give tone guidance. We want to tell it you want to be friendly, and then we're going to give it some other guidelines. The big things here are that we want to tell it you're going to be communicating over SMS, so keep your responses brief. When you want to make a booking, make sure that you have the customer's name and their email before you start the booking. And then we tell it how to use the tools. And so I'm going to come back to that in a second. Then at the end, I like to give an example conversation. I like to show it, this is what we would expect. If you get this input, we would expect this output. And so you can see each step of the conversation for it to be able to see what a conversation should look like. So zooming in on our system prompt and how we define those tools, we can tell it, if you don't have a customer's full name, ask for it before you book an appointment for them, and then use the update customer tool to update it. And I'll show how we define that tool in a minute. If the customer wants to book an appointment, use the find available slots tool to find a spot for them to book. And then once they have provided a time, use the book appointment tool to book it. So then we're also going to have JSON definitions for our tools. And so these tool definitions are going to tell the LLM, we gave it guidance on when to call the tools. Now we need to give it guidance on how to call those tools. And so we're going to tell it, when you need to book an appointment for the current customer, you're going to call this book appointment function. And it's going to take some parameters. It's going to take a start time. Well, for book appointment, that's the only parameter, is it's going to take a start time. And the start time should be in ISO 8601 format. Then we have another tool for finding the available slots. And this one has two parameters, a start time and an end time, so that you have kind of the window to search. And then our final tool is the update customer tool. So this one can take a first name or last name, and they're both optional fields, but it allows you to then update that customer. So then we can dive into the actual handle incoming message function. So if you remember, when we receive the webhook, we're going to call our handle incoming message function on the agent. The handle incoming message is going to take the message body and then the customer info. And the first thing it's going to do is it's going to see if we already have conversation data for that customer. So in this case, I'm going to store that conversation state with OpenAI. You could store this in your database. If you have kind of long-running agents, you could store this in memory for your application. And that all kind of depends on what your needs are. But usually, for me, the easiest is just letting OpenAI store that for me. And so when we create that conversation, we're going to tell OpenAI, let's create a conversation, and we're going to start with our system prompt. We're going to provide the system prompt so that it knows how to interact with that user. But our system prompt needs a little bit of extra context that's going to be dynamic. So we're going to wrap our system prompt, and then we're going to provide the current date and time, because the LLM doesn't know that. We're going to provide the customer information, because that is going to change with each conversation that our LLM has. And so we're going to provide those in the system prompt, and we're going to create that conversation. Then back in our handle incoming message function, we're going to call OpenAI's responses API to get the response to whatever message the user has sent. And so you'll notice we're providing that new message as input. And that's going to concatenate our system prompt that is already in the conversation with this new input. Then we're going to receive the response from the LLM. And what we want to do is we want to parse that to see if it has any function calls. So if the LLM returned that it wants to call functions, then we're going to need to handle those. But if it didn't respond with any function calls, we know that we have just a text response. And so we can return that so that it can be sent as a text message. So if we did have function calls, though, we can run those as promises. We can map over those function calls and call our useTool function, which I'll get to in a second. And then we can wait for all of those tool calls to finish. Once we've received the responses to all the tools, then we can return those to OpenAI so that then it can generate the final response with those. And so basically, we're creating this, we have what's called the agentic loop. In this case, we've only gone through it once. We've said, check once for function calls. If there were no function calls, then we're going to return the text. Most agents are actually going to do this in a loop. They're going to look for function calls, and then they're going to call the LLM again with the response and see, OK, now are there more function calls? And if so, they keep doing that in a loop until they have a final response. But because we've built a very simple agent, we don't have to do that. So I'm actually not going to show you how this works. I'm going to let you try it out. So if you text this number, you can book an appointment with our Alpine Pup Parlor, and you can see how this works in real life. So again, my name's Dennis Beatty. I have QR codes here for being able to follow me on Twitter if you'd like, or to see the GitHub repo. You can download the code, you can run it yourself, modify it, and try building an agent. Honestly, it's the most fun that I've had with programming in a long time, and I think that it's something that everybody should try out. So yeah, text it, try it out, and I do have a little time for questions. I don't know if we're doing that. Yeah? OK, does anybody have any questions? Yeah? How do you deal with the AI not doing the right thing? Yeah, unfortunately, that is a very common problem. There are several frameworks that help with that. There's one that I really like called Boundary ML that helps to give you the right response, the right type, the right shape to your response every time. But honestly, that's something that takes time to figure out. There are a lot of people have created what's called evals, where you actually run tests against your agent to make sure with these inputs we're getting the output that we want. Typically, though, you won't see evals ever get to 100%. You're always just trying to get those as high as you can. And honestly, it's like working with humans. If I work with someone in customer support, they're not always going to give the response that I think would be best. But by training those, by running those tests, and then by changing your prompt slightly to kind of take care of those edge cases, over time we can get it better. But it is really hard to get it to 100%. I should say impossible. Yeah?
Yeah, how do you prevent a function
Yeah, typically what you'll do is you'll set a max limit for how many functions can be called. And yeah, again, it's one of those things that because AI is, and because LLMs are non-deterministic, it's really hard to prevent, but you can write kind of guardrails for that in your app. Sorry, I'm staying on this, yeah, up here. How much does it cost and what does it do to your margins? Yeah, so are you talking about for Surge specifically? Yeah. So with our registrations, it's because that's a one-time thing typically, it's pretty cheap. If you are sending millions of LLM-generated messages, that's when it starts to get really expensive. But if you're just using it for small tasks like this, we're paying pennies. Okay, so we're down to 30 seconds left. So if you have any more questions, please feel free to come find me. I'll be outside in the hall for a little bit. I also do have some Surge stickers if you're interested, if the stickers on the table outside weren't already enough for you. So please come find me and say hi. Thank you.